again, we can't do any of this work without the bases matching. And the base, by the base I mean like this component. Okay, so to date you would have worked on things like linear equations would have been grade 9, right? Solving for x. So something like 4x would equal 13 plus 3, and so you would have seen 4x would have equaled 16, divide both sides by 4, so on. Everyone okay with that? That was this is like linear solving. And then in grade 10, we would have moved on to quadratic solving, which would have involved factoring, right? And so I could have found two numbers that multiply to negative 48. What am I doing? Negative 48 and add to negative 2. And then we could have found the numbers and factored it and then solved for x. That's what we've done before. Now you've been exposed a little bit to these exponentials. Like at least the equations. And so what makes an exponential is that the variable in question is going to be in the exponent now. Okay, so when we are trying to get left side equals the right side, it's a little trickier from the standpoint that like we're trying to figure out what has to go in for x so that I get 2 to the power of some number makes the left side equal the right side. So it's a little bit different, right? A little tougher. Okay. So again, the exponential equation is an equation where the unknown is in the exponent. Okay, so for example, you can see you have 2 to the power of 3x minus 2. So that x is now up in the exponent, which makes things a little bit trickier. Okay, the key to solving this type of equation is to establish a common base. Okay, that's like the two green components that are in the question. You have to make those match. And so a lot of the time, or most all of the time, you're going to have, you know, if your base is 2 on the left, then the number on the right should be represented with 2 to the power of something in order for these questions to work out. The harder word problem ones is a little bit of a trial and error, guess and check basis to figure out what exponent you need to put on the right side in order to get the base of 2 to work out, or whatever it is. Okay, so if 2 powers are equal, then they have the same base and the exponents must be the same. Okay, so that's important. Once you make those bases match, you can equate the two exponents together and solve for x accordingly. Okay? And hopefully that makes sense as we work through here. So steps. Write both sides of the equations with the same base. That's will be the first thing. And then since the bases are equal, the exponents are equal. And then you're just going to use your solving tactics that you've had over the last couple of years to solve for x. It could be a quadratic, it could be a linear equation. And that's all you really know how to do. Okay, so for instance, let's come down to question A here. Okay, I'm looking for 2 to the power of x. What value of x makes 2 to the power of x equal 32? Okay, so this one's a little bit like you can solve this one with inspection by looking at it. Okay, Robbie's saying 5, but let's see if we can figure out, using the process I'm alluding to with the 3 steps there in the box, how we could figure that out. So the base is 2. So my goal here is I need there to be a base of 2 here in order for this question to work out. And my question becomes, what has to go in the box so that I get 32 on the right side? That's my question. Okay. So Robbie says it's 5. 2 to the power of 5 gives me 32. Is everyone in agreement with that? Okay, so if I put this to 2 to the power of 5, now you can see that the bases match, and I can ignore them. Okay, and I'm just solving in the exponent. So in this case, you're just going to get straightforward x equals 5. Can we see that? We'll get rid of the loop there. So that's how you solve these equations, and as we go through a few of these, I think it'll start to click a little bit more, okay, by the time we get through 9 of these questions. Okay, again, question B, your job is to make the bases match. So you get 3 to the x plus 1 has to equal 3 to the power of something. What is that something? 3 to the power of something has to equal 81. That's your question. 3 to the power of something equals 81. What needs to go in that box is your question. Reese? 4. Everyone in agreement? 3 to the power of 4 gives me 81.
We have like calculators.
You have calculators for this, yeah. This test is very calculator heavy, right? You saw already, like, how do I input rational exponents? That's an important part. Another important part is when we get into the word problem portion of this, you're going to have numbers that are not necessarily nicely cubed or nicely squared or anything like that. You're going to have to figure out through trial and error what you need to put in at the exponent in order to give you the number you're looking for. So you're going to need a calculator for that. Okay, and that's the application portion. Okay. Okay, once the bases match, you can ignore them, and you just get a linear equation here now. X plus 1 equals 4. Everyone see? And so now you just solve for x. So x has to equal 3. You can do a little check with that, right? By checking, okay, if I put in my answer here of 3 into the left side, I should get 81, right? And so I'm going to go 3 to the power of 3 plus 1 is equal to what? Well, that's 3 to the power of 4. That equals 81. Okay? Everyone okay so far? Okay. They do get a little bit, you got to be careful sometimes with what's happening, particularly in the next question. Okay, again, the steps don't change. It's just maybe some of the math does, and you just got to be a little bit careful, okay? So again, need to make the bases match, so 2 to the x minus 1 has to equal, how do I represent 4 with a base of 2? So it's 2 to the power of something. What's the something that I need? Again, I'll just write it out. 2 to the power of something needs to equal 4. What is that something in the box? 2. Okay, so that's the name. That's like a big part of this process, and then it's just your solving skills from that point forward. Okay, so I know, now just be careful with this, 2 squared is equal to the 4. Okay, and all I'm doing is changing the 4 into something that looks different but still gives me the same result, and then I need to deal with the exponent that's there as well. Dylan?
Could 2 also equal, or x also equal 1, so they're both 2 or 4 to the power of 0, and they're both 1?
I don't. Maybe 0 is the answer. I'm not sure yet. Yeah, I'm not sure. So we'll just run with it and then ask your question again if it's not 0. Okay, and then I can try and make sense of it. Okay, so bases match, so ignore them. They're gone, and you just get this: x minus 1 is equal to 2 times x minus 1. Okay, and then you could distribute the 2 in. X minus 1 is equal to 2x minus 2. And then what? Solve for x. Okay, so I can go negative 1 plus 2 has to equal 2x minus an x. And so I get 1 is equal to 1x when I solve. And again, you could check to make sure that this was actually true by taking our answer and doing a left side equals right side check. Just like your linear equations, except they're not linear anymore. They're exponential equations, which is kind of cool. Is everyone okay so far? Okay, we'll do a couple more. Okay, the next one. 3 to the 4x minus 1 has to equal 3 squared. Because 3 squared is equal to 9. Once the bases match, you ignore them, and you get 4x minus 1. Oops. 4x minus 1 has to equal 2. 4x is equal to 3. Divide both sides by 4. x should equal 3/4. I did a couple things there, so just stare at that, make sure you're okay. All right? Okay, is everyone okay?
Bless you.
Okay, 4 to the 5x minus 3 has to equal. How do I represent 16 with a base of 4? 4 squared, very good, you're catching on, good. All right, 4 squared. Now just be careful, the exponent doesn't go anywhere, that's there. Okay, so you gotta represent it as x plus 1. Okay, and so now, bases match, scratch them out. You just get the what's left in the exponents there, right? 5x minus 3 has to equal 2 times x plus 1. 5x minus 3 has to equal 2x plus 2. 5x take away 2x has to equal 2 plus 3. So again, like maybe at the beginning of this, you might have been able to evaluate these or like look at them and solve them by just looking at them, but they are going to get tough. Okay, stuff like that. It's a little tricky to maybe figure out that it's 5/3 is going to be the answer. With these. They're okay. Okay, I do kind of enjoy these. They're not that bad. I don't know. Okay. What about the next one? I suppose that's something new that you maybe haven't seen. How are you going to make that work? Gabe?
Flip the 125.
Buddy, that's good. And what do you do when you flip it?
It makes the 125 negative. It makes it a whole number.
Like negative 125 or what? Because you're being a little bit vague with your language. I'm just trying to push you in the right direction. So here, I'll write something, Gabe. You tell me if you agree or disagree, because I'm in question right now, which is good. You're on the right track. Is that what you meant to say? Because that's how I interpreted what you said.
Yes.
Okay, is that what we do when we move things from the numerator to denominator or vice versa?
Yes.
Is it? Gabe got you about 95% of the way there. Reese?
5 to the negative 3.
5 to the negative 3. Oh, yeah, one sec, buddy. One sec. I want to deal with the negative component first. When we move things from the numerator to denominator, it is not the number that becomes negative. It is the exponent. Not fraction. The exponent becomes negative. So it's 125 to the negative 1. Everyone okay? You can move things from denominator to numerator anytime you want. You just need to make the negative or the exponent negative. Okay? If it's already negative, then a negative times a negative turns it into a positive. Okay? Now, to Reese's point now, we're in the situation of the rest of the other 5 questions we've done. I need to make the basis match. So how do I make the basis match? Well, 5 to the 2x minus 1 has to equal, I need a base of 5. 5 to what exponent gives me 125? 3. But it's 3 times negative 1. And so I'm left with, now that the bases match, Okay, and I can add 1 to both sides. And I get 2x is going to equal negative 2. Divide both sides by 2. X is going to equal negative 1. Everybody okay? Hmm.
Maybe you should slow down.
Okay, is everybody okay? Gabe, yeah?
Wait, you said we were gonna.
$2.
Oh, as later. Apologize. Never mind. I'll stay quiet for now.
What's your question?
Because we're gonna eventually start graphing these, correct?
Oh, yeah. That's a whole separate lesson. I gotta show you that. Thomas?
How did you get a -5?
Oh, it's -3, sorry, but yeah, I was a little worried I wrote that kind of. Okay, just for clarity's sake, that's from right here. 3 times -1, okay? Sorry, let's see. Sorry.
Yes, babe.
Okay, everybody okay? Same idea. What do I do here?
Look, bro. 1,024 to the -1.
Okay, so 4 to the x plus 3 has to equal 1,024 to the -1. I know, and you know now, I need 4 to the power of something. 4 to the power of something, this is maybe where you're going to need your calculator. 4 to the something is going to be 1,024. I don't know what that something is. How could you figure that out quickly?
4 times 4 times 4 times.
Okay, I suppose.
I did.
How about you tell me if I'm right or wrong? I'm just.
Wrong. You're wrong.
Could you not take the 4th root of 1,024?
Yeah, probably. No, because it's to the -1.
It doesn't matter. The -1 we'll deal with in a sec. I only care about the 1,024. What is the 4th root of 1,024?
5.
5.65.
Is it really? Does that work then?
Wait, like, are we talking 1/4? What are we putting?
No, like this thing on your calculator. I'm just speculating. I don't know if I'm just thinking off the top of my head.
No, I don't think that does work.
No, because it's 4 times 4 times, like it's 4 to the power of 5, so then
Okay, fair enough. Okay, it'll be the 5th root.
yeah.
Be the 5th root. Sorry. So maybe no quick way to do that then. Aside from just like, you know what the base needs to be, take it and multiply it by itself a few times until you get to the number that you're looking for. That might be the fastest way then. Sorry.
No way it's rush hour.
Good choice. Okay. Base is math, so it's 4 to the power of 5. Now don't forget the -1.
Wait, it's.
This is too speedy.
It's because you're doing a lot of chatting.
We don't chill. As if I haven't even said
Okay,
one.
get right.
Do you remember who bought you a coffee? Oh shit, seriously, it's Tim's.
Is everybody okay? Okay, next one's a little trickier. I want you to think about this for a second. You don't need to write this down. I'm just going to communicate this to you. Can I combine things that are not the same base?
No.
No. So you are not distributing that 3 to the inside of that bracket. Gabe?
You divide the 3 over to the other side?
You divide both sides by 3. That deals with the 3. And wow, look at, we get 5 to the x plus 1 is equal to,
5.
wow. So that means what's the exponent on 5?
1.
Is it 0?
Oh, the
Really,
X,
Dylan,
X,
is
here,
it?
X, X.
Is it though? You were wrong too. No, I said 1. What is that to you?
I got the same answer by doing
So it doesn't
distributing
work then?
3 into everything.
It's real.
You do 3 distributed to 5. and
You
then-
can't do that.
Yeah?
You cannot combine things that do not have the same base. You cannot apply the power laws.
Stop doing that. Stop doing that.
Alright, I'll stop you.
Okay?
Okay.
Last one. This is a nice one.
Travis. There was one thing, he like flipped it over and then like volleyed it. I didn't even know. It was really cool. Remember I yelled, "You're nasty."